Hello and welcome everyone to my channel Code with Ease. This is the third video in linked list series, how to detect loop in a linked list. So we are given a problem statement in which the linked list has n nodes and we have to check whether the given linked list has a loop. So what does a loop mean? We know that a linked list has a head node and a tail node. The last node of the linked list points to null. In the scenario where the tail node is again connected to any of the existing nodes is when we have a loop. We have to detect if that is the scenario with the given linked list or not. So in the first example that is given, these are the three nodes 1, 3 and 4, and x, this is the position at which tail is connected, that is 2. And the output is true because we can see it is explicitly mentioned that the tail node is connected to some other node. Okay. And similarly, in the second example, we have 1834, x is 0, means the tail node is not connected to any other node, so it is returning output is false. So explanation is saying x0 means last node dot next points to null, so it does not contain a loop. So our work is to return whether it is a linked list having a loop or it doesn't have a loop. If it has, we have to return true, else we have to return false. And the time complexity is order of n and space is order of 1. So with this, let's move to the whiteboard to understand how do we solve this. First, let's define one linked list that already has a loop. So we'll have 1, 2, 3, 4, 4 will point to 5, and then 5 will point to 6, and 6 will point to 3. So this is a linked list which has a loop. So what our question is asking us to do, that we have to detect the loop and then return it accordingly. So if there is a loop, what would be the brute force way of detecting this? So let's discuss that. And let's also note the time and space complexity for doing this. Order of n, space was order of 1. Okay. So what's the brute force way? So in this, let's say if we start traversal of the linked list, at what point we can say there is a loop exists? We start from here, we come here, then we go to the next, then next, then next, then next, and then we come back to this. In this we can observe that since it is coming back to one of the previously visited nodes, so in that case we can say that this node is kind of a redundant node. So because of that reason, we can try to use hashing. So we can use a set. We know that set can only allow unique characters inside, unique elements. So what we can do is start from here. When we go here, here, 4, 5, 6. But the moment we come to 3, we will see that 1, 2, 3, 4, 5, 6. And then when we come here, we'll see that 3 already exists. Because it already exists, because of that reason, it will say, yes, there is a loop. So this is the brute force way of doing. Why this is not optimal? Because we are using a set, and set will have some additional space required. This is going to take some additional space, which is not permissible because we have to solve it in order of 1 space. Okay. So now let's try to see what would be the optimal way of doing this. So now I would like to introduce an algorithm called Floyd's cycle detection algorithm. As part of this algorithm, what it does, there are 2 pointers that is being used. We call this slow and fast pointers. Slow and fast. So in this what happens? Let's say we have few nodes here. The slow and the fast pointer will initially point to the first node, the head node. Because as the name suggests, it's a slow pointer, it will move 1 node ahead. But since it is a fast pointer, what it does, it moves 2 nodes ahead. So it will move here. And then again slow moves 1 node ahead. And fast will move 2 nodes ahead. Okay, so this is how it works. How will this algorithm help us? Let's check that out. So back to the linked list which has a loop. So let's say we start from here. So we have the slow pointer here, and we also have the fast pointer. So now slow pointer moves one step ahead, but the fast pointer will move here. Okay. Then slow moves here, and fast, instead of going here, it will go here. Slow moves ahead, slow is here, and this time fast will be here. Then slow is here, and fast this time, because it will 3, will come to here. So now we see slow and fast are at the same node. So what this algorithm suggests is we'll have these 2 pointers, will make it move accordingly, 1 pointer for slow, 1 node for slow, and 2 nodes for fast. When slow and fast meet, or I mean not when, it's like if they meet, yes, loop exists. If not, then it was a single non-loop linked list. That's the simple algorithm. That's it. So we have seen from the above diagram how we can determine if we can detect the loop by the movement of the slow and fast pointers, and as they meet, we can say that yes, there is a loop that exists. Okay. So with this, let's try to see what should be the code for this. Let's start with the code changes. So we are given this is the method detect loop. We have a head reference. So let's define our 2 pointers, the slow and fast pointers. So we'll say slow equal to head, and the fast is also equal to head. Okay. While fast is not equal to null, and fast dot next is also not equal to null. In that case, we are going to move our pointers forward. So slow will be slow dot next, and fast will move 2 times forward. So fast will be fast dot next dot next. Okay. After incrementing, after making these move forward, we also have to check here if at any point they're meeting each other or not. This check we have to do. So if they are, then a loop is detected. A loop exists. Okay. If that's the case, then we have to return true, because we just have to detect the loop. Okay. If it is not, then we'll keep on traversing. If this condition is never satisfied, means there is no loop at all. So therefore, by default, it can return false. And talking of this while condition, why are we writing these two? Because if let's say we have these are the nodes with us, that 1, 3, 5, 6, 7. What can happen is either it is here at the last node, the tail node, and the next of this is pointing to null. So this means it has already come to the end. So there is no chance of having any more loop. It has already reached it. So that is why we are going to break the while loop by writing this condition. Otherwise, what can happen is it has already fast has moved forward to the null. So there can be 2 things. Either fast was at 5 and from 5 it jumped into 7, or fast was at 6 and it jumped 2 times and it came to null. So in either of these cases, we can say there is no loop, because if it was already at 6 and it jumped forward, then it jumped forward means it jumped to a null pointer. It means there was no loop. If it was a loop, then it would have jumped to some other node and not to the null. And if it is here, or if it is at 5 and it comes over here, means it has reached the end of the linked list. And we are saying here, if the end of the linked list it has reached and it is pointing, the next is pointing to null. Means again, same thing, the tail node is not pointing to any existing node, it is pointing to a null. So if it is pointing to null or if it is itself at null, in both the cases, we have to break the loop. Means there is break the while condition. There is no loop. So that's why we have given this condition. And we have returned false. Yeah. So that's all about this. Let's try to run this. Okay, we'll submit. Okay, so this is solved successfully. Okay, so that's all about this problem detect loop. In the next videos, we are going to increase the complexity of the problems and make use of these existing concepts only to solve some more interview related questions. Thank you so much for watching this video.